Earlier, we discussed multiplication of binomials. This topic is factoring of a binomial and is a reverse operation. Before I go any further, let's go and discuss this mathematical term factoring. When we multiply two numbers and we get a result, these two numbers that are being multiplied are called factors. Let's take a look at an example. So 4 times 1 plus 2 in the brackets equals. And then the result of this multiplication is a product. 1 plus 2 in this case is a binomial. A binomial consists of two terms normally put in the brackets, and multiplication of a binomial by a number goes the following way. We multiply the number by both terms of a binomial. So in this case, it would be 4 times 1 plus 4 times 2. And as a result, we get 12, which is our product. Factoring is a reverse process. For example, given 12, we may be asked to factor it, and our two factors might be 4 and 1 plus 2. Or it could be, of course, 4 times 3. So in this case, 4 would be a factor and 3 would be a factor, or 4 is a factor and 1 plus 2 is a factor. So when we refer to factoring, it is the reverse operation. When given a certain number, we break it down into two factors. Here is an example of a binomial, 16 plus 8. What makes it a binomial is that it has two terms, 16 and 8. If we were asked to factor this binomial, here is what we're trying to do. We want to identify a common factor for both of these terms and then see what we can do with this. So let's take a look, and what we can probably notice is that 16 and 8, they both have number 8 as part of them. So if we were to factor 16, we would get an 8 times 2. These are two factors that would lead to 16. The 8 we can factor into 8 times 1. And what we get now are two terms that have been factored, and they have a common factor 8. If we were to pull this common factor outside of the brackets, what we would get as a result would be 2 plus 1. And to understand why that is, just try to reverse this operation. And what you get is 8 times 2 plus 8 times 1. And this is exactly the preceding step. If we were trying to solve it, at the end we would get the answer of 24. But this is beyond the point of this exercise. The point of this exercise was to factor a binomial. And to factor a binomial means that represent this binomial as a product of two factors. And this is exactly what we accomplished. We went from 16 plus 8 into a factored form of 8 times 2 plus 1. Here is another example, 4a plus 2a. This is a binomial, and we're asked to factor it. In order for us to factor it, we need to identify common factors of both of these terms. Term number 1 is 4a, and term number 2 is 2a. If we look at it, we can see that both of them have one common factor that's very obvious, which is a. This variable a, or the unknown a, is in both term 1 and term 2. Now let's focus on the second component of both terms, numbers 4 and 2. Since this is relatively easy to identify, we can see that both 4 and 2 share a common factor 2. So we can factor 4 into 2 times 2 and factor 2 in the second term into 2 times 1. And as a result, we get 2 times 2 times a plus 2 times 1 times a. At the next stage, we will pull out common factors in both terms, and they are 2 times a. Once we do that, what we're left with are 2 plus 1. To check if we did a good job, we can reverse and multiply 2a times 2 and plus 2a times 1, and we will get exactly the same what we see in the preceding step. We successfully factored the binomial 4a plus 2a, and in the factored form, it is 2a times 2 plus 1. As you noticed, we handled separately numbers and the variable a. Let's look at another example that will demonstrate how to deal with more complex situations. 7a squared b in the ninth minus 14a in the fourth times b cubed. This may seem like a head spinner, but stay with me and we'll do just fine. Let's first focus on the numbers 7 and 14. We can clearly identify that they share a common factor 7. So let's have 7 as 7, or 7 times 1. And let's break down 14 into two factors, 7 and 2. And since we have minus 14, it would rather be minus 7 times 2. Now, at the next step, we'll focus on the variable a. To understand this next step, you'd need probably to refer back to our discussion of power and exponent. So if we're given a in the second power and we have a in the fourth power, we should understand that a in the fourth power is a squared times a squared. And we can also represent it as a, and in the exponent, we can have a 2 plus 2, which exactly conveys the same thing I just discussed. As you can see, a in the second in the first term and a to the fourth in the second term share a common factor of a squared. Using the same knowledge, we can see that b to the ninth in the first term and b in the third in the second term also share a common factor of b in the third. So we can break down b to the ninth as b, and then in the brackets 3 plus 6. And in the second term, we'll just leave it as a b cubed. Let's now look at both terms in this format and identify common terms, the ones that we can pull outside the brackets. And we can see that both first and second term share number 7, so that goes outside the bracket. Then we have a squared, that is also a common factor of the two terms. And finally, we have b in the third as a common factor of the two terms. What we're left with in the brackets is b in the sixth minus, we have 2 left, and a squared. So 7a squared, b in the third, and in the brackets, b to the sixth minus 2a squared.